In this problem, we're given that k of x is continuous and differentiable over its entire domain, and we're asked to use this table to determine where the relative maximums, minimums, and inflection points could be. In order to find a relative maximum and a relative minimum, they're going to happen at critical points. Critical points are those values where the derivative is equal to 0. After determining the critical points, now we look to the second derivative to help us determine whether they're going to be minimums or maximums. The second derivative talks about concavity. When the second derivative is negative, then the curve is going to be concave down. Since x equals negative 2 is a critical point, so its derivative is 0, that means the slope of its tangent line is 0, and we're talking about this point here. When it's concave down and at the top of that curve, that means it's a relative maximum. So the relative maximum occurs when x is negative 2. On the other hand, for x equals negative 1, its second derivative is positive, meaning it's concave up. Because at x equals negative 1, there's a critical point. The slope of the tangent line is 0. It means we're at the bottom of this curve, making it a relative minimum at x equals positive 1. When it comes to the inflection point, what we want to look for is the second derivative being 0. And that's not all. We have to also see if the derivative changes concavity as it passes over here. And when we go from x equals negative 1 to x equals positive 1, at negative 1, the second derivative is negative, meaning it's concave down. So the curve would be concave down. After that, it changes concavity and becomes concave up, making x equals 0 an inflection point.